Greetings to all. Today our group is going to present our assignment for the course Statics and Mechanics of Material. Hello, my name is Lianjing. My matrix number is 22004693. In this assignment, we have chosen wheelchair as a real-life example for further investigation through the study of statics and mechanics to improve the current design of the wheelchair. From the perspectives of statics, a wheelchair is treated as a rigid body which is at rest. The forces acting on the wheelchair are determined and further analyzed. Generally, different magnitude and types of forces can act at different points on a rigid body. These forces may have positive or adverse impact on the rigid body as well as the wheelchair in our case. In the study of mechanics, factors due to axial loading, pure bending, and torsional load can lead to deformations of a structural member. To cite an example, the structural components of a wheelchair will fail by the action of stretching, compressing, bending, or tearing. Therefore, it is important for us to perform any calculations and analyze the factors which may cause failure to a wheelchair.
My name is Tesylia Jong Hui Xin, and today I'm going to talk about the methodology. So the first case is the forces on the wheelchair. The steps taken are that we first select a 10 kg wheelchair, and then we measure the length between the front caster and the wheel, as well as the length between the two opposite wheels, and then we determine the force of the person by using this equation W equals to mg, and then we assume the center of gravity that is shown in this diagram. So next we draw a free body diagram and we determine the force of the caster and the force of the wheel by using this equation, total force Y equals to 0 and the total moment of caster equals to 0. So now moving on to the second case, which is the internal moments and forces in a wheelchair axle. So first we select the same 10 kg wheelchair, and then we measure the length of the axle and the radius of the wheel, and then we determine the force of the person, as well as we draw a free body diagram. Next, we determine the vertical force of axle as well as the horizontal force of axle by using these two equations, and then we determine the moment of axle by using this formula, total of moment axle equals to 0. Now the last case is the shear stresses on boats. So we select the same wheelchair and we measure the circumference of the boat to determine the diameter using the formula where circumference equals to 2 pi r. And we determine the force of person. We draw a free body diagram and we use the equation A equals to pi d squared over 4 to determine the area of the metal. And then we determine the shear stress using the formula shear stress equals to force of person over the area, as well as we calculate the value of the shear strength. So after that, we will compare the both values of shear stress and shear strength.
I'm Diane Dia. I will explain the calculation part for these three cases. For case 1, we need to calculate the force on a wheelchair. The length between the front caster and the wheel is measured, and also for the length between two opposite wheels. Then we get these two values for calculations. The mass of student is equal to 50 kg. Then we apply this formula F equal to mg, and we obtain the force of person is 490.5 newtons. Referring to the free body diagram, the total Fy is equal to 0. Then we obtain this formula. We use the equation total moment of caster is equal to 0. Then we can know that the force of the wheel is equal to 112.11 newtons. Then substitute the values of force of wheel into equation 1. Then we can get the values of force of caster is equal to 133.14 newton. For case 2, we must calculate the internal moments and the force in a wheelchair axis. The length of the axis and the radius of the wheel are measured. We use these two formulas, total Fs equal to 0 and total Fy equal to 0, to get the values for force axis horizontal and force axis verticals. Then we use these two values to calculate the force of axis is equal to 693.67 Newton. Then we apply the equations total moment of axis is equal to 0 to obtain the values for moments of axis is equal to 109.872 Newton meter. For case 3, we need to calculate the shear stress on boards. The circumference of board is measured. We use the values of circumference to calculate the diameter of boards, which is 0.8276 cm. The stress of steel is given that, and we know that it is 33,000 Newton per cm square. To calculate shear stress, we use this formula, tau equal to force of person divided by area. Area is equal to pi d squared over 4, and we can get the value 911.818 Newton per cm square. For the shear strength, we need to divide by 2 and get the values is 16,500 Newton per cm square. It is much larger than the shear stress, so it means that the board is plenty strong enough for the express.
I'm Casandra Lee Ying Hui, metric number 22004695, and I would like to present about the discussion part with my another groupmate, Toh Ka Peng. For discussion part, we separate it into two, which are forces that may cause failure and the solutions, as well as the assumptions. We have determined some forces and factors that may cause failure on the wheelchair, that are overloading, shearing stress, and corrosion. The solutions we figure out are follow the recommended limit, consult with a physical therapist, perform structural analysis using seat cushions and back supports, as well as painting. Next, let's move on to the first factor, which is overloading. Overloading decreases the stability and further increase the difficulty for maneuvering, and finally the wheelchair becomes inoperable. This may be due to the overloading put extra stresses on various components. For example, overloading caused the frame to bend, brakes to wear out more quickly, the wheelchair difficult to stop. If the user cannot correctly distribute their weight in the chair, they may experience pain or discomfort. The first solution regarding to the overloading is follow the recommended limit. Users should check the weight limit before buying a wheelchair. There are some crucial measurements such as seat width, back height, seat depth, and seat to floor height. There are various types of wheelchair, which are transportation wheelchair, lightweight wheelchair, standard wheelchair, and tilt wheelchair. Thus, users are advised to choose the wheelchair wisely. The next solution is consult with a physical therapist. This may help the user to get guidance on selecting and using the right wheelchair that fulfill their needs. The next factor is shearing stress. Shearing stress occurs when forces are applied perpendicular to the surface of an object. In the wheelchair, shearing stress has put excessive pressure on the mechanical parts of the wheelchair and caused it to bend, warp, break, or become loose. For example, wheels can be damaged or dislodged and making noise when rolling. The solution to solve the shearing stress is perform a structural analysis. Firstly, calculate the loads and forces on the wheelchair. This may involve both statics and dynamics loads. Next, the material used in the construction should be taken into consideration. Next, determine the material properties such as strength and stiffness. Lastly, compare the calculated stress to the allowable stress for the materials used. Another alternative is using seat cushions and back supports. This may distribute the pressure more evenly, and the footrest also help in preventing shear stress. Next, users should also avoid placing heavy loads on the arms of the wheelchair.
I'm Toh Ka Peng with metric number of 22004663. Now I'm going to present about factor 3, which is corrosion. When the oxide coating of metal, such as aluminium and stainless steel, has been damaged, corrosion may occur. Corrosion occurs when exposed to damaging chemicals, sunlight, grease, moisture, or heat for prolonged periods of time. When corrosion occurs, the wheelchair may dismember if there is presence of too large external force applied to the wheelchair. Meanwhile, rust causes stiffness and decreases the stability of the wheelchair. Lastly, the appearance of the wheelchair will be bad. The solution for corrosion problem is by painting. Painting can avoid exposure of the metal to the oxygen. We can coat the metals with a rust-inhibiting primer and followed by paint that is formulated for use on metal. We can use a brush or roller to paint and let the paint dry in between coats. There are 5 assumptions for our project. The first assumption is the wheelchair is new without undergoing any damage or worn-out issue on its body parts. Next, the forces applied to the parts of the wheelchair are in equilibrium. Moreover, the forces applied to the wheelchair should be assumed to exert equally and completely on the seat. Furthermore, systematic errors need to be ignored during the measurements of the dimension of the wheelchair's parts. Lastly, no movement of the wheelchair by the wind or external forces.
To sum up, we have investigated the wheelchair by applying the knowledge of statics and mechanics that we have learned throughout this semester. The wheelchair is assumed to be stationary for us to perform equilibrium-based analysis. Free body diagrams are drawn to show all the forces acting on the wheelchair. Not to mention, we have also identified possible factors and forces which may cause failure to a wheelchair. Through the calculations of shear stress, we have concluded that the shear strength of the board is greater than the shear stress experienced by it. Last but not least, further studies and research are believed to improve the functionality and suitability of a wheelchair in the near future. These are the references that we have used in completing our report. That's all from our group. Thank you.